So I will now the pleasure of introducing now Professor Dusan Rozenbergar. It's a pleasure, not a bigger pleasure than Gal or Tom, because it was a pleasure too. But Dusan was just returned back home in Ljubljana after spending 3 months in my lab, in my office in Viterbo. So it is during an Erasmus exchange project. So it'll be very much a pleasure to have you here and speak about his research on silviculture in Slovenia. So please, Dusan.
Yes, hello. The sound is okay?
Yes, perfect.
Okay, I want to thank you for the invitation and, of course, for your hospitality. We'll discuss this later on. And from my side, I will present some information about which is more connected to silviculture. So, as you can see, this is a large and very ambitious title. And of course, in this time frame, it's impossible to actually cover it really well. So what this presentation will be more like a drops of information. And then maybe later on, if there are more questions or discussion, we can continue the let's say the transfer of the information. Okay. So I'll just start with the really general question: what is silviculture? Which is basically defining which are the aims of our activities in the forest. So silviculture is actually trying to guide the development of the forest to meet some needs that are there for society or for the forest owner. And to do that, you need to be aware of these 3 very important factors that depend or that influence the silviculture a lot. One of them is, of course, the ecology. So this is what is there in the nature that we manage. The second one is economics, and of course, the society. So the silviculture needs to know, or the silviculturist needs to know all these 3 fields pretty well, because he needs to do something that's in between. So if we start with the natural forest, so when the ecology is 100%, let's say, taken into account, there's no management here, and there's no silviculture here. But we need to know natural forest, because this is actually the very basis of any sustainable provision of any kind of ecosystem services. So this is something where we start actually our silvicultural treatments. And in the past few centuries, actually, the most important part of these 3 factors were economics. And as a result, this is the case. This was the case in Europe, but also globally. So there was like centuries of really controlled forest management, which completely changed the forests from natural to this far from natural form. And the result of this management was reduced diversity, reduced species, but also structural diversity. Then the resilience is really low of this forest. The biodiversity is low. And also we have much larger susceptibility to different disturbances, which were discussed before from Tom and Alfredo. So at the same time, because of the changed structure, there's also like a big reduction of different ecosystem services which could be provided from this forest for the society. And as a result, more close to nature forest management started to develop, so to tackle all these problems that are connected to the like this economic forestry, I would say. So what we want to do is come somehow First, we started with natural forests, but we only have fragments now of these forests, as Tom explained. Now we have most of the forest that we are dealing with now is in this condition, which means far from natural forest. And what we want to do, we want to get more close to this, close to nature, let's say, type of a forest or structure or a stand. So what does that mean? What is close to nature according to different definitions? But here we have some general points that's supposed to be taken into account when we want to manage a forest in this close to nature way. So what we want to do is do a lot of retention of habitat trees. Tom discussed this and Alfredo. So deadwood is very important habitat in forest ecosystem. Then we want to promote native tree species because they are very well site adapted, and we want to have natural vegetation. Then regeneration of the forest should also be natural. So we should not use too much of artificial regeneration. So one of the goals of the close to nature management is to have natural regeneration. Then we want to promote structural heterogeneity. According to Tom and also Gal, the resilience and the resistance of the forest, which is heterogeneous in terms of structure, is much higher. We want to promote species and genetic diversity and avoid very intensive management operations. So also on the landscape level, this kind of forest should take care of the heterogeneity on this larger level. So according to some research that was done on the European level, here you can see the results of this study, and this figure is showing the proportion of silviculture system used in Europe. And we have the total proportions, and then we have also separate for boreal forest and more temperate forest. What we can see from this analysis is that most of the forest in Europe is managed in different type of large-scale uniform silviculture system. So here we have uniform shelter wood or clear-cutting system. Most of the forest in Europe are managed in this way. And if we go on, so the more close to nature or uneven-aged forest management is not present as much as we would want, but there is some, you can see. So continuous cover systems are still something that's not generally applied on the European level. So the question is, when we do want to have close to nature silviculture, so we get all these very important ecological traits of this forest, but the question is, can we also have a high quality timber and enough wood for firewood, let's say? And this is what I will be discussing now, a few slides. So if we do want to go more close to nature silviculture, we need to do some tending. We need to apply different tending measures. And first of all, there are different silviculture systems that could be defined sorry, as continuous cover. And like just some of them are listed here, the most common ones. So we have single tree selection, which means we are selecting individual trees, and we have different age classes in the forest. Then we have group selection when we manage on a level of a small group of trees, and also the openings in the canopy are like really small. The next one is a regular shelter wood, which is also called Femmelschlag. I guess there's going to be more information about this later in later presentations. And also much less defined and highly locally adapted freestyle silviculture, sometimes also called Dauerwald. These are not the same, but they are all in a group of, let's say, close to nature or continuous cover forest management. So first, sorry, first a photo of the classical selection forest. What does it mean? You can see we have a completely filled vertical profile with vegetation. We have all different ages and dimensions of trees at the same time on the same place. And this kind of management is relatively intensive if you want to maintain it. And what we are looking here for is that you need to have constant recruitment of young trees into your forest, which means you need to take care of the structure. So the structure of this forest is intensively manipulated, and you all the time want to have all these parts of the stand as they are marked here with white arrows. So you need to have good regeneration that is ready to go on, and then you need to have well-developed middle layer. And of course, we need to have the adult crop trees, which are actually the aim of this management. So this system is relatively unstable, and it needs a lot of intervention. So what happens if we are not doing it properly? We don't have good intensity, or the timing is not good. This structure that was described here, you can see it also in this sketch here, can easily turn into something which is less diverse in terms of structure and goes into layers. So there are certain rules how to manage selection forest and starter tables. And so it's an intensive management that you need to do, but you get a lot of positive effects out of it. This kind of management is really good for late successional species, which are normally also shade tolerant. In our case, this is silver fir, Abies alba, beech, Fagus sylvatica, and sometimes also spruce, Pizza abies. But this kind of system is not so good if you want to have more light demanding species. So in this case, when your goal is set to different diversity and higher proportions of light demanding species, irregular shelterwood is the system which enables this goal. So here you have larger canopy gaps, and you can see the areas of different ages of the forest, and the much more opportunity to get more light demanding species. Here you can see that the development of the forest is marked with this sketch, and what we can see here is at which part of the development the silvicultural treatment is the most effective. So it's during the young phases of the forest. So if we want to guide the development of the forest, we need to start really early in the development, because at that stage our measures are most effective, and in this stage of the development of the forest our influence is the largest. So why do we want to start early? Because let's say for the production of high quality wood, the lower part of the stem is the most important one, and this one is defined during the younger phases of the development of the tree. And there is a general rule, I guess you know it. It's 30, 60, 90, which means 30% of the log length equals 60% of the log volume equals 90% of the log value. Sorry, the log volume is the 60. So you have 30% of a length and 90% of the value of this log. So this is the most important part in terms of economic revenue for the forest. So every irregular shelter wood, let's say, cycle begins with a gap like this, and these gaps are then later enlarged. And we start with regeneration, possibly natural regeneration. After we develop this further, we have two possibilities. So we can do some indirect tending of young forests, which means we are using the stand above us to create certain ecological conditions and to protect the regeneration below. Or if we choose to go more fast in our development, we can partly cut all the upper trees, and then we do some direct measures in the forest. So if we go with the indirect tending, this is one typical picture of a forest like this. So you can still have nice growth of the above high quality trees. At the same time, this regeneration is protected underneath, and that's why it's also very successful, and the next generation is ready to take over after we cut these trees. If you have more open areas, that on the second hand gives you more opportunity to do some direct tending in this young forest. And also, what is the most important part here, you can do a lot, or you have a lot of influence on tree species composition. So you have high quality forest after you do some tending measures here. The next step, or let's say already a few meters high trees, and here you can see we have maple, we have different tree species, we have beech. So in these mountain ecosystems, especially in central Slovenia, most of the Slovenia, beech is the most dominant tree species. So if we want to have a mixture of other tree species, more light demanding, we need to do this tending really early in the development. Every time we are just fixing ourselves on the upper part of this population, because these trees that are on the top are the most healthy ones, and also the most, let's say, they have the highest probability of a good development in the future. Sometimes if we don't have good regeneration naturally, we can also do some additional planting, and in this case you choose some species that are like sometimes more minority species, but they have really good influence on the forest, on this forest ecosystem in terms of their, let's say, fruit-bearing species. They're good for the animals, but also very, very popular in terms of wood production. Of course, when you have these first developmental stages of the forest, you need to do some intensive intervention like this. Most of the time, it's about the vegetation, which is competing with our trees. And let's say this is one example when you have really a lot of vegetation, and after the treatment, you can see there was a tree that was planted below. I have the same situation here. There were some oak trees planted. There's a lot of vegetation, and after the treatment, you can see we release these trees, and this release needs to be done, let's say 2-3 years after the planting, and after that you already get trees that are high enough. They don't need to do this anymore, but it's an investment that you need to do. So as the stand develops, we go into selective thinning. So we are still reducing the number of trees, and we are trying to do some management also later on. So selective thinning is actually a crown thinning, where you select the best trees and try to promote their development. So this is the second part of the development, let's say, of a forest like this, and this is where we do the selective thinnings. As one example, let's say we have two approaches. One is this thinning from above, which is actually the selective thinning. Sometimes you can also do thinning from below. In our case, we try to promote positive selection, which means we're trying to find good trees and help them in their development. At the same time, we don't want to reduce all the bad or negative trees with the negative selection, because then we decrease the structure of the forest if we do that. So this selective thinning starts in a development phase like this. You can already see that some trees are good quality and that they are proper tree species. And in this case, we would be selecting some of these trees, and the selective thinning is prolonged then into later stages of the development of the forest, let's say like this, pole stage, and also later young mature stage. So what do we do when we select a tree and promote it? As one example, let's say we can every time, let's say in the tree that is selected, it is in the middle, and we try to improve the growing conditions for the selected tree. That's why we, let's say, reduce or cut the tree which is close. This is, in most of the cases, we take out one tree for one selected tree. Sometimes if the density is really high, we can, let's say, reduce the density in a way, one selected tree, and we remove two trees that are competing. Not more, because if we do more, the stability of the stand is already could be problematic. So what happens after the thinning? You can see we have some change conditions in the forest. There is more light, but also better growing conditions for the selected trees, which grow faster. They have bigger crowns. And also what happens is that with this selective thinning, we have higher DBHs at the same heights, which means better stability of the trees, which are more capable of resisting against different disturbances, which is quite a big problem, especially lately. You can see situations like this, there's not much you can do. So here, the thinning was not done early enough, and then, of course, the consequences are not so good. Sometimes, if we want to even improve the quality of our forest, of our trees, we can do some pruning, which means that we reduce the lower branches on the trunk with the aim of getting really high quality wood like this. And there are different systems that are developed and also used. Here, let's say this is one system which was proposed by Speaker, two-phase system of pruning the trees, and after we get the selected height of really nice log, then the next steps, we just make sure that the crowns are really big. So these trees are growing fast, they have big crowns, and therefore also the quality of these trees is improving really fastly. So this is one example of a pruning like this. So lower part of the stem is pruned, and from now on we will take care of this crown to be growing really fast. Another example, only selecting the most quality trees when we do our treatment. What is important here is that we spend a lot of time and effort with these selected trees. The important is that we have a really good quality of intervention inside the forest. So these kind of photos are not really good. So it's not just about the theory, but also the practice is very important. You need to have good team of workers, which you need to educate so they don't do this, because after you damage a selected tree, or your costs are like lost, actually. So this is one example. This one is from Switzerland. These trees were treated with pruning, and you can see this is a cherry Prunus avium tree which has 30 years old, and it has 30 centimeters in diameter. So soon it's gonna be a market tree with a lot of value. Next example, this is Fraxinus excelsior. So you can have really high quality, light demanding tree species also inside a forest like this. Or if we go further on, this is also one stand of Quercus robur. And bottom line, so if we do silviculture early enough in this phase, let's say our goal is to get here, so to get some good quality trees. Just a few examples. What does that mean in terms of market? What is the market for these kind of trees? And we have an yearly auction in Slovenia, which is covering like the whole Slovenian area with good quality trees. And these are some prices that were reached in the last 2 or 3 years. And let's say for Acer pseudoplatanus, like here, you can see the prices for cubic meters are around 10,000 euros per 1 cubic meter. Let's say this year, 2023, the winning log was valued at 14,000, 15,000 almost euros per cubic meter. So the whole log was sold for 23,000 euros. But not just Acer pseudoplatanus, you also have oak. really nice prices. You can see this year, almost 2,000 euros per cubic meter, but also other species, let's say Larix, Decidua, Mathiasen, quite large. Also, this year's price was, let's say, around 1,000 euros per cubic meter. Also spruce, good quality spruce is valued like material, also 1,500. And then at the end, this minority, more light demanding species, you can see Prunus avium, Pyrrhus pyraster, and also Ulmus glabra, really nice prices for different pieces of wood. So it can be done. At the end, our goal is to have something like this. This is the forest which has good tree species diversity, a lot of diverse structure, as you can see. Because of that, it's resistant, it's resilient, and it can provide really wide range of different ecosystem services, which also include high quality timber and firewood. So yeah, thank you. That's all from my side.
Thank you so much to turn on the less conservative aspect, but utilization, looking to even deep management, but looking to quality and biodiversity as well.